Welcome. Today, we're diving into the fascinating chemistry behind Aqua Regia. This powerful mixture combines hydrochloric acid and nitric acid, two strong acids working together in synergy. We'll explore how their interaction creates something unique, with properties far beyond what each acid can do alone. Let's get started. Let's talk about Aqua Regia, often called the royal water, because it can dissolve noble metals like gold and platinum. It's not just two strong acids thrown together. Instead, it works through a powerful chemical synergy. Hydrochloric acid provides chloride ions and an acidic environment, while nitric acid brings strong oxidizing power. Together, they create a highly reactive mixture that's far more effective than either acid alone. This unique combination is what makes Aqua Regia so special. Gold is famously resistant to chemical attack, especially by acids that don't oxidize. Take hydrochloric acid. It supplies plenty of chloride ions, but it can't effectively oxidize metallic gold on its own. Without that initial oxidation step, gold just won't dissolve. On the other hand, nitric acid is a strong oxidizer and can convert gold into ions, but without enough chloride ions, those ions aren't stable or soluble. So, to dissolve gold, we need both oxidation from nitric acid and complexation from chloride ions working together. Let's dive into the powerful synergy between hydrochloric acid and nitric acid. When these two are mixed in concentrated form, they create a highly reactive chemical system. This isn't just one simple reaction. It produces reactive species like nitrosyl chloride, chlorine gas, and nitrogen oxides, all in a delicate balance. Why does this matter? Because together, these species create an environment that's both strongly oxidizing and chlorinating. The mixture combines oxidizing power, high chloride activity, and strong acidity. It's a dynamic, ever-changing system, not a single stable compound. Let's talk about platinum, another noble metal that's tough to dissolve. Aqua Regia can break it down, thanks to a process involving oxidation and chloride complexation. In simple terms, platinum forms soluble chloroplatinate complexes, which helps it dissolve. The chemistry is complex, with various nitrogen oxides and chlorine species playing a role, depending on conditions. For gold, the process starts with oxidation, followed by reduction, and then chloride ions form stable complexes, turning solid metal into a dissolved species. It's a delicate balance of electron transfer and stabilization. Let's talk about why the 3-to-1 ratio is so commonly used in this chemical mix. It's all about synergy, the way these acids work together. Hydrochloric acid is in excess because it provides the chloride ions needed to form stable metal chloride complexes. For metals like gold and platinum, this is crucial. Meanwhile, nitric acid acts as the oxidizer, starting the reaction by breaking down the metal surface. Together, they create a continuous chemical driving force that keeps the metal dissolving. Of course, the exact ratio can vary depending on the specific metals and conditions involved. Aqua Regia plays a crucial role in chemistry and analytical labs. It's famously used to dissolve noble metals like gold, platinum, and palladium, though the conditions for palladium need to be just right. It's also key in preparing samples, especially when metals need to be broken down for analysis. In trace metal analysis, it helps get samples ready before instruments do their work. And in the lab, it's carefully used to clean equipment by removing stubborn metal residues, always with strict safety controls. Let's talk about why fresh Aqua Regia is so hazardous. It's not just a simple acid mix, it's a reactive chemical system. After you mix it, its composition can change as reactive gases and species form. This means it's highly corrosive, creates a strong oxidizing environment, and can release toxic nitrogen oxides and chlorine-containing species. It also generates heat and pressure, especially in closed containers. So we must follow strict safety procedures, use proper controls, avoid sealed containers, and handle waste carefully. Never treat Aqua Regia like an ordinary acid. Let's wrap up with the key points behind the Aqua Regia synergy. First, oxidation. Nitric acid creates oxidizing agents that turn metal atoms into oxidized forms. Then, complexation, chloride ions step in to stabilize those oxidized metal ions. Next, the mix of hydrochloric and nitric acid produces a dynamic blend of reactive chlorine and nitrogen species. Finally, the thermodynamic driving force. By removing or stabilizing these oxidized metals, the process keeps the dissolution going strong. This synergy is what makes Aqua Regia so effective. Did you find this explanation of chemistry helpful? If you did, please like the video. It really helps us out. We'd love to hear your thoughts, too. Why do you think neither hydrochloric acid nor nitric acid alone dissolves gold as well as Aqua Regia? Share your ideas in the comments. And if you know someone in chemistry, pharma, or quality control, share this video with them. Don't forget to follow and subscribe to the Siphacos channel for more science and quality insights. That brings us to the end of our presentation. For any further support or questions, please don't hesitate to reach out. Thank you for your time and attention. It's been a pleasure sharing this with you.